Welcome, everyone. Thanks for taking the time to come meet with us today on a very important topic for our industry. My name is Lance Campo. I work with the marketing department at Clean Air Industries, and we've prepared a series of webinars for our industry that we're going to be hosting this year. We've done one before. This is our second one. We have some special guests today, and we're going to be talking about combustible dust and NFPA 660. We're excited to have a panel of guests, and our special guest today is Dr. Chris Cloney, Managing Director at, the website is Dust Safety Science. Chris, I think you go by DustX Research, is that correct?
That's correct, yes.
Okay, and he'll be giving you the latest breakdown on the changes for NFPA 660 that are coming up. From Clean Air Industries, we have, who's no stranger, Mark Edgar, our Senior Vice President. He's been a figurehead in the industry for more than 30 years. We'll also have Kevin Costello, the Senior Mechanical Engineering Supervisor, and Evan Harmon, Applications Engineer, all from our Clean Air Industries team. And at this time, I'd like to hand over our presentation to Dr. Cloney. Dr. Cloney, can I call you Chris for this presentation? Oh, you're muted.
Yes, you certainly can. I couldn't get unmuted. Now I am.
There you go.
Yes, you can.
Okay, I'll invite you to take screen control at this time, and let's get started.
Excellent. Thank you, Lance, for the introduction. Thank you for the panel of Clean Air Industry folks that we have here today. And I'm excited for the audience as well. I see a couple of familiar faces, Francesco, Terry, Scott, Marty in the audience, and a ton of other interesting folks as well that I've seen their names around combustible dust. So I'm excited for this session with the group. I want to say thank you to Clean Air Industries for hosting. In my short contribution to this, we're going to cover a lot of groundwork. We're going to cover what are the NFPA standards. We're going to cover 660. What is it? What's the same? What's different? How do you access it? If you have questions, where do you go to get those answered? And we're going to cover briefly dust hazard analysis. Really just give you enough information on what kind of resources are available out there in this space, and hopefully get some really good questions going with either myself or the Clean Air Industries team after this session as well. My background is in originally defense research. I was working with a consulting company that worked with the Defense Research and Development Canada, which is our defense industry, on high explosive research. So think, TNT, ammonium nitrate, stuff that goes, bang really quickly. I did that for the better part of 7 or 8 years prior to starting my academic research in the world of industrial dust explosions. I did that from 2011 through 2018. It all told me about eight or 9 years to get my academic degree in this stuff. During that time, I started what eventually became Dust Safety Science, and then the Dust Safety Academy, and then the Global Dust Safety Conference, and Dust Safety Professionals, and now is the Combustible Dust Training Institute, which is our most recent rollout and evolution of what we're doing, educating folks on combustible dust safety. Our mission since 2018, when we incorporated DustX research, is to have at least 1 year with 0 fatalities worldwide by 2038 from dust explosions. No, we haven't had it happen yet. There actually, I don't believe, has been a year since at least the 1900 that we haven't had a fatality from a dust explosion just in the US or at least in North America since that time. So that's what we're working towards. We build a number of educational platforms related to combustible dust safety. I've done a lot of talking on the subject. Dust Safety Science podcast is up over 300 episodes in the last 5 years. Personally been involved in 150, 200 webinars covering combustible dust. I definitely do not have all the answers. Feel free to ask any question though. If I can't answer it here, if the Clean Air team can't answer it here, we'll get your question answered for you. So that's what we do. I did mention that we have recently rolled out the Combustible Dust Training Institute. That's certifications and training around combustible dust safety. This is something you're interested in, just let me know and we'll discuss that as well. I did put access to the slides here. So I got the slides and a couple of cheat sheets on some of the specific materials. If you want to access that, the easiest way, my email gets flooded all the time. So the easiest way is just go to LinkedIn, connect with me, and message me slides plus Clean Air, and I'll send you these slides afterwards. plus some of the cheat sheets that the team put together. You can just simply use your phone here, scan that, it'll take you to your LinkedIn, connect, and just shoot me that message. I'll send you the slides afterwards. What is the problem with combustible dust? Why are Evan and Kevin and Lance and Francisco and Mark and myself here? I guess I added Francisco, he's on my screen, but he's not a Clean Air Industries guy. But why are we here talking about combustible dust safety in the first place? This photo is from the Imperial Sugar Refinery explosion in Savannah, Georgia, one of the more infamous combustible dust incidents. This had a lot of fugitive dust. Several stories of several buildings completely demolished from secondary, tertiary, fourth stage, fifth stage dust explosions happened. So that's kind of one example, one scope of the problem. But the challenge with combustible dust is it's much more broad than that. This is an explosion that's zero fugitive dust, only exists inside of ducting, from a mill, grinding application up to the roof, cyclones, down back in dust collector, projected back in the building, blew the back corner off. No fugitive dust, very high level of destruction. You also have cases where you have explosions just in, we'll call them small, I mean, that's not a small dust collector, but small pieces of equipment, bucket elevators. So you have large losses with sites and tertiary and quad, the four-stage explosions, all the way down to small piece of equipment. Case where there's tragic loss of life. This is an aluminum dust explosion in Kunsheng, China, with upward north of 150 fatalities. And you can have more personal safety issues. This is Kyle Flicker. He was in a coma for several months after a rubber dust explosion in Blaine, Minnesota, I want to say, although I'm not sure if I got the state right. Might be Missouri. No, I think it is Minnesota. The point of showing you these images and the cases and the examples, and the Clean Air Industries team would be able to tell you this too, is that there's just a wide range for combustible dust. Just in those short slides, just in that 3 minutes, I've talked about rubber, aluminum, wood, grain, talked about fugitive dust with dust all over the place, real lack of cleaning and collection. Talked about no fugitive dust, still entire loss of a building. We talked about personal safety, impact on one person. We talked about site safety, impact on entire building. That's the big challenge we have for combustible dust in general, is we have a lot of different range of scopes, a lot of different range of size, a lot of different range of materials and industries that we're working with. And so the overall summary then is, wouldn't it be nice to have a structured way to identify the materials that cause the hazards in the first place, to analyze where and when these hazards come up, to evaluate what safeguards are needed, and then recommend and track progress against improving these safeguards. And that's the sole purpose of the dust hazard analysis process as outlined in the NFPA standards, is to give you that structured way, or to give a qualified person that structured way to assess these hazards, given the breadth and width and depth of the challenges that are associated with combustible dust. There's been a lot of talk recently about NFPA 660. Some folks haven't seen it yet, so just in case you don't know, any NFPA standard is available online for free. Just go to nfpa.org/the standard number. I'm actually not sure that's true. I don't know if any NFPA standard, but every combustible dust one, 652, 61, 44, if you go to this URL with that number, scroll down, you can click view free access. You have to create an account, so not completely free, you gotta give up your email. You can view the entire document. So if you have questions about anything in this presentation, or if you see something like, hey, I wonder what that section says, you can access it. I personally use NFPA Link, which I find very quick and fast compared to the old method of printing off reams and reams of paper and trying to scroll through the thing or flip through the thing to try to find the material you're looking for. You can access it free today. This is the structure of we'll call the past NFPA standards. 652 was the system that outlined that systematic procedure for completing a DHA, how to identify the hazards, how to assess them, how to address them, what management systems put in place. And then it called out to the green squares, which are the commodity or industry specific standards for agriculture, sulfur, metals, wood processing, and other dusts. It also called out to the how-to standards, so deflagration venting, deflagration prevention, and the NFPA 70 electrical code. That was how the standards align. Each one of these was a different document in a different order created by a different committee. And so it was good in a sense because you knew what was contained in it, but it also took a lot of work. You had to read all of 652 and then all of 61 if you want to understand the grain, what to do in a grain handling facility. The focus for NFPA 660 then was to combine the fundamental standard and those commodity and industry specific standards into one document. So the layout is chapter 1 to 10 is 652. Then chapters 21 to 25 are the commodity specific standards. So the really nice thing about laying it out this way is that things are nested. So for example, I'll probably get this wrong, but we'll say 5.1, let's say 4.3. Section 4.3 would be, I believe, the requirements for owners and operators in a facility handling combustible dust. So that's what you find in chapter 4, section 3. If you want to know what additional requirements there were for owners and operators in a grain handling facility, that would be chapter 21.4.3. If you want to know the additional requirements for owners and operators in sulfur, it'd be 24.4.3. And so all the chapters, all the sections are nested in this way where you have something in the fundamental chapter, say bucket elevator protection, that's probably up in 9.8. You want to know bucket elevator protection for a woodworking facility, be 25.9.8. And it makes it a lot faster. If you want to know bucket elevators between wood and the fundamental standard before, you'd have to read the entire fundamentals document and the entire 664 document. And because things didn't align, you have to try to figure what that meant. So it made it a lot harder. So it's a lot faster to get around, a lot easier to use, even though it is a very large document. So that's the layout for NFPA 660. Again, you can access that free. These are the general requirements. This was the section I was actually referring to. I guess 4.1, not 4.3. I'm not one of those folks that has the chapters fully memorized that can rattle off the fourth subsection right away. The requirements for owners and operators in facilities handling combustible dust really have three components. One is identifying the hazards. So this is your combustible dust testing. The second is to assess those. So this is your requirements for performing a dust hazard analysis. And the third is managing or addressing these hazards. This generally has two components, managing the hazards themselves in the equipment, and then also management systems, more like emergency response, training people, those sort of things, housekeeping programs. Those go in a separate chapter. Those are your compliance options. So that's really the three processes that you'll see in the NFPA standard related to dust hazard analysis. Identify, do your testing, assess the hazards using dust hazard analysis, then go ahead and address those hazards with what was identified through the DHA process. In terms of testing, the first step in identifying the hazards is generally doing a screening test. This is a cheaper alternative and a faster alternative to doing a full range suite of tests. If you get the results back from your screening and determine that you do not have a dust explosion hazard, then you don't have to go through and do the rest of the requirements related to doing a dust hazard analysis. If you come back positive from your screening test, then you kind of go one or two routes, looking at understanding your explosibility parameters. Those are the ones that are outlined like KST, MEC, LOC, MIE, and MIT in the slide here. And now, well, it always was you had to look at combustibility and flammability as well. Now it explicitly calls out in NFPA 660 under particular circumstances that you need to look at flammability parameters as well. So that kind of gives you an idea of the range of tests that may be required when you're looking at combustible dust. I think this is one of the cheat sheets that we pulled off and put in this kind of package that we have for these slides as well, if you want to grab those. I'll give you a really basic breakdown of a DHA process. One is determine, do you have a combustible dust? To do your screening test. If that's positive, then you break your processing operation to a list of nodes. Add nodes for rooms, buildings, and buildings enclosures. Evaluate the hazards, evaluate the safeguards, then document your hazard scenarios, your safeguards, and how they match up against the prescriptive requirements in the NFPA standards. So in those chapters on management systems and equipment protection. So you think of this, if you had a really simple process, say we had something that's shredding metal components, you have an input hopper, a shredder, an output bin, and dust collectors attached to it, then we take a sample probably from the dust collector, do screening tests on it, find that yes, it is explosible. Step 2 is the nodes. So you have your input bin, your input bin, your shredder, your output bin, and your dust collector, plus the ducting between them often will be treated as a node, and the room itself will be treated as a node. That's because you want to assess the hazards at all those locations. The room itself, do you have fugitive dust in the room? If you do, then you need to, or do you have the possibility for fugitive dust in the room? If you do, then you need to evaluate the existing safeguards to prevent that, like dust collection, like having a housekeeping program. Same as in the input bin, the output bin. The input bin, maybe you're putting, I don't know, electronic boards in there. Okay, there may not be a combustible hazard, so you don't need to deal with that in your DHA, or you can exclude that. Where on the shredded side, maybe you do have combustible powder that's built up. At the end of the day, you're looking to come with that list of safeguards that are in place and comparing that to the prescriptive requirements and NFPA standards. That's the most basic approach. There's more complicated versions where you can use other DHA methodologies, risk-based assessments, performance-based assessments. This is a really simple example where you're comparing against the prescriptive requirements for the NFPA standards. We want to dive into some more detailed examples. There is one in NFPA 660, which I believe you can access from the free version. Just go to Annex B, and it gives you sort of a worked out DHA example. Use some more scenario-based than the node-based one that I explained. But that will give you an example. There's 2 books here. The one Guidelines for Combustible Hazard Analysis is probably the most effective. It has a lot of really good examples. Covers both prescriptive requirements and risk-based requirements. So that'd be a really good guidebook for you in this case if you're looking deeper into this topic. We also have certifications and courses that we built out for this thing as well. So just to close out, then I'll give you, this is the list of changes in 660 from 652 and the commodity industry specific standards. I'm happy you don't have to say that all the time anymore. It'll be good when we don't say 652 plus commodity and industry specific standards. It's quite hard to say that. But this list is actually in the front of NFPA 660 in the origin section. This tells you, okay, we tried to make this change with most things staying the same, but here are the list of things that actually did get changed with substance between these 2 standards. I'm not going to go through all of them, but I'll point out a couple that might be relevant to you. There are requirements now for operational readiness reviews to be done as a management system. So this is sometimes called a pre-startup safety review. If the equipment is down for a long enough time, or you're starting a new piece of equipment, there's requirements for what kind of review needs to be done before you turn that on. There are new requirements to evaluate self-heating, thermal instability, and water reactivity under certain circumstances. That was sort of always included in evaluating fire, flash fire, and explosion hazards. Now it specifically spells out or explicitly spells out when those would be required as part of your assessment. There has been some text added in a few places on the level of protection by flame-resistant garments. This is something that's newer to the standard, but it's something that we see running our combustible incident database in terms of the protection that employees have when they're impinged on from a dust deflagration. Really important. There are specific elements now on general safety training and job-specific training, the frequency with which those need to be completed with your workers. And the last ones I have here, some guidance on responding to silo fires. And there have been more requirements added to ag and food in terms of the type of equipment that needs to be assessed during a dust hazard analysis. So that's it for my contribution. Again, this was really meant to go through high level 660, what's new, and a little bit on dust hazard analysis, give you some resources you can walk away with, and really set the stage for the clean air folks to talk through things as well. So if you have any questions for me on those topics, please send them through. Again, you can download, or I'll send you the slides. Just connect with me on LinkedIn, message slide plus clean air, and the team will know which set of slides to send you. So that'll be great. So Lance, without further ado, I'll give it back to you.
Thanks a lot, Chris. Just to refresh for anybody that's joined us late, you're watching NFPA 660 and dust hazard analysis, what you need to know. Our special guest today is Dr. Chris Cloney, and he's just walked us through, as you've heard, some really important updates to the 660 standard. Really interesting, Chris. I do have some questions for you myself, which I'll save to the end. So at this time, I'd like to hand it over to our Clean Air Industries engineering team of Mark Gedger, Evan Harmon, and Kevin Costello, who are now going to discuss some of the equipment solutions that Clean Air Industries offers and some of the applications that we typically see in the field. And I believe, Mark, you're going to be headmanning this for the beginning?
Yes, Lance, I am. Can you see my screen?
Yes, sir, I can. Looks and sounds good. I'll leave it to you.
All right. Good afternoon, everyone. So I'm going to talk a little bit about the equipment that we have that we provide for different solutions that would meet the NFPA 660 compliance. So typically dust that we deal with, ST1 dust mostly, with KST of less than 200. And those types of materials are like charcoal, powdered milk, sugar, zinc powder, fiberglass, those types of dusts. We can do ST2 dust as well, but that just takes some calculations to make sure that we are within the range. We have dealt with other things, other types of dust as well, plastic dust, food processing dust, tobacco, sugar, wood dust, and various metal dusts. So the primary equipment that we carry that we use for dealing with meeting the NFPA 660 compliance is the first one is our ATV series equipment, our dust collectors that has the vertical dust collector cartridge. Our second primary equipment series is the ATH, which is a horizontal cartridge collector. So the ATV series and the ATH series both utilize the same size cartridge. One is in a vertical orientation and the other is in a horizontal. We also have the ATC Cyclone series. Cyclones mostly are used for wood dust. Sometimes they're used for other applications. You can see in that one picture there with the horizontal unit that it's actually in a thermal spray operation. It was heavy sparks, and so it's being used to remove the sparks. And then lastly, we have our ADT series, which is our line of economical dust collectors that run from 2 cartridge, 4 cartridge, and 6 cartridge. So the secondary equipment that we would apply to our equipment to meet the NFPA 660 compliance is rupture panels, as you can see in this photograph here, flameless vent in case the unit is inside, rotary airlock, and just a reminder that the rotary airlock needs to meet NFPA 660 compliance. That is 8 vanes, a certain tolerance that's needed between the vanes and the housing, and that the bearings are outboard. Explosion isolation valves, and here you have what we refer to as a vigiflap. These would go on the inlet duct of the dust collector. And just a reminder that you have to have a certain distance depending on the size of that vigiflap, distance from the vigiflap to the dust collector. Also on the return air, you can return air into the plant, but you need a vigiflap or explosion isolation valve on that. And it will be a fixed flap system and requires a greater distance. Really important to get those distances correct, and also to make sure that the ductwork that is between the vigiflap and the dust collector meets at least 2 times the P rate of the dust collector. Here's a high-speed abort gate, mostly used in wood dust applications. Here you see an explosion vent deflector that can be applied to the vent or rupture panel in the case of maybe it's pointed towards a parking lot or areas where people pass. So this can help shorten that throw of the flame. Chemical suppression systems, we offer those too. Mostly we find those go into the food industry or sometimes plastics industry, mostly related to when either the dust that's been captured is being recycled, or that the distance from the outside wall to where the piece of equipment is significant, and it's just easier to have it inside. And then finally, spark detection systems that could be utilized as well. So we offer all of those secondary pieces of equipment that can be applied to our dust collectors. I'm going to hand it over to Evan Harmon now.
All right, thank you, Mark. Going to take us through some installed applications here. Here we've got some pictures of our ATV40. It's on a fiberglass dust application. On the far right of the screen there, you can, of course, see the Vigiflap on the dirty air side going into the dust collector. And, of course, you can see the rupture panel on the side of the collector itself. And then a dual airlock system, or 2 rotary airlocks at the bottom of the hopper. Here we've got an ATV24. It's on a polycarbonate dust application for an optical lens manufacturer. Again, on the dirty air side there, you'll see an NRV valve, abort gate. You've got, of course, the rupture panel on the front face there of the dust collector you can see, as well as the rotary airlock at the bottom. Here we've got an ATH 432. This particular application is on a welding and grinding process. You can see to meet the NFPA 68, we've got the vent deflector there on the right-hand side, closer to where you can see the fan and the stack. What's not shown is on the left-hand side of that dust collector, there is a rupture panel to meet code, and of course an NRV valve. Here we've got an application that's on plastic dust. Again, on the right-hand side of the picture there, you can see the NRV valve. There's rupture panels on the left-hand side of the unit that's a little out of view of the picture. And on the bottom of the dual hopper there, you can see they've got rotary airlocks. This particular application was all set up where you can see the duct is kind of floating out here, where they got everything set up. They had the electricians come in and make sure everything worked well to have the least impact for interrupting the process of this particular plant. And one thing I would like to point out is a lot of these pictures you'll see today, or you have seen, are applications where they are outdoors. We do have the capability, of course, to do indoor applications. You heard Mark talk about the equipment offerings that we have that are able to allow for that capability. So what we could do is just have a site visit where we'd come out, take a look at the application, and basically help you determine whether that's an instance where we would have to drop the dust collector outdoors or indoors. We don't always have unlimited floor space with a lot of these applications, but also there's the challenge of not being near to an external wall. So we would basically help you analyze what would be the best option, the most cost-effective for those applications. And I'll hand it over to Kevin.
Yeah, thanks, Evan, and thanks everyone for joining us today. And I would hope that some of our attendees today will recognize actually some of these projects that we've done. I'm going to finish out speaking on one more installed project, and then actually some current projects we've been working on here at Clean Air Industries. So this unit is a pretty custom unit that was a tobacco application. It contained a chemical suppression system that was food grade compliant as well, on the dust collector, as well as the inlet and outlet ducting. And there's also an abort gate with a spark detection system on the clean air discharge that was returning back to the plant. And this unit also had rotary airlocks installed on it as well. We designed this unit. We had to have it PE stamped and also approved by FM Global and a third-party reviewer for this customer. And this is actually one of the submittal drawings for that project. And this just goes to show some of the capabilities our engineering department can help our customers or distributors or any prospective clients and getting these projects approved, where you have to make sure your T's are crossed and your I's are dotted to make sure everything is safe and compliant like it should be. And then to go to some of our current projects, actually, this is a 44-inch, 50 horsepower cyclone with a rupture panel, rotary airlock, some of your standard devices, as well as a vent deflector designed and fabricated by us here at Clean Air Industries that's built to NFPA 68 standards. There's also a current project we have of a 44-inch cyclone that does not have a blower because it's actually going on the inlet of a cartridge dust collector. And it has a rupture panel with a braking sensor as well as a rotary airlock and also a pressure sensor mount that we integrated on this cyclone to be intertwined with the dust collection system on the cartridge dust collector that's going with this cyclone. So we're very flexible. Our engineering department can help in any way we can to make sure these systems get designed right and are to our customers' needs. So thank you, everybody.
All right. Thank you very much, Kevin. So we're ready to take questions from our guests. We have one lined up currently. I'm not sure if you guys can see this on the side of your screen. Let me know. The question is, what is being done to educate the manufacturing space? I have seen universal ignorance, without exception, of anything to do with these requirements. Is this something that seems to be a problem in the industry, Chris? Are you seeing a lack of education in the manufacturing sector?
Yes, I don't know if I call it universal. I mean, there's 48 folks on this call, or 38 folks on this call that get it. So, but it is a big challenge. There are lots of sites that that either have no requirements or even not a full understanding of the requirements that are needed. You saw a lot of the clean air systems that are fully protected. It's not uncommon to see a site that would have only some of those protections or some not applied in a very safe manner. Even the deflector plate example that I think Evan showed, or maybe Kevin showed, where you see that vent pointing directly at an ingress or at an emergency exit. Those are all challenges that you see quite commonly, and that's the importance of doing webinars like this. So yeah, not universal, but still a challenge, still something that we're trying to go for.
Mark, what would you say in response to that? You've seen a lot of people in the field on a month-to-month, week-to-week basis. What can you offer in terms of insight?
Yeah, Lance. Yeah, I agree with Chris. Yeah, I think we see out there that there is a lack of education with the end users. And, just to point out, it is the end user who's responsible for those situations. And, yeah, I think everyone's meant to, by this time, have completed a dust hazard analysis. Chris, is that correct? Yeah. So, and that dust hazard analysis, that's part of what it's meant to do, is to reveal situations that are unsafe. And I can say personally that I've been in factories where when they see the dollars attached to it, that all of a sudden things get a little bit squirrely. So, but what's most important is keeping the people safe in the plants.
Interesting. I have a question to throw out there. When you're doing a dust hazard analysis, what is the process for a facility that's under a new design that has not been built, where some of those processes might not be producing because the equipment doesn't exist and they're not exactly sure what type of combustible dust might be being produced by those new factories? What can you do in that instance?
Yeah, it's a really good question. And it's actually a great place to be. I wish everyone was doing their DHA before the site was, even though it presents some unique challenges, but generally not as unique as the challenges that come up on an existing site and trying to deal with old equipment and stuff. So generally we call them a desktop DHA, or that's the most common name here for it, is a desktop DHA. But one where you're looking at the typical types of materials that you'd be handling. You may come up with an envelope for your explosion, your testing parameters for your design. It's really about trying to figure out the best way to integrate. But you can design out a lot of issues that are going to come up with an existing facility with the right provider. So it's actually a great spot to be in. It's just a matter then of really you also have all your documentation at that stage, which is really nice. With a 60-year-old facility, you don't necessarily have all the design drawings, but where your greenfield, I'm hoping you have them. Otherwise, you're going to be in trouble in the near future. So it's a good spot to be in. It's not uncommon to be done. So it's done quite a bit, and there'll be lots of providers that can do that for you.
Fugitive dust, that's a term that I'm not familiar with. So I'm glad that you mentioned that today. I'm going to be thinking about that one for a while. We have another question here. This is for anyone that wants to answer. Should every customer have their dust tested? Are there applications where it's fairly obvious that there wouldn't be a combustible dust present? Is what they're trying to get at there.
So I can jump in unless one of the clean air folks want to answer first. You can always opt in and say, yes, my dust is combustible. So that's step one. And you may have a basis of safety that doesn't require any testing. If you're going to start sizing vent panels, there's certain protection mechanisms that are required to know the rate that explosion is going to happen. And those are going to require, or if you're using different ignition source safety, you may need to keep your ignition sources below the minimum ignition energy, or the temperatures of the surfaces below the minimum ignition temperature. Any of those kind of cases, once you get to design your safety barriers or your basis of safety, you're going to be looking at, well, what tests do you need to run? But there are bases of safety that can be defined that don't require testing. So it's not a requirement. You can always opt in and say, now, if you're not sure if your dust is combustible, it is really, it's really quite hard to say it's not combustible because we know it's not combustible unless it's glass.
Yeah, that's what I was getting at. I'm thinking of stuff like stone cutting or gypsum, but then again, you may not know what binding materials are with the stone dust and stuff like that.
Yeah, for a long time, they used to say that welding fumes were oxidized and non-combustible, and that it's still debatable from a physics point of view to me if that's true, because we have lots of fly ash explosions, which is the same thing but with coal. But the point there is we've seen more and more weld fume explosions, but it's not necessarily the weld fumes, it's all the other stuff that's going on in the welding application, what you're cutting, what you're grind, like the base materials that you're involved in. So it is quite difficult to opt out. A screening test isn't terribly expensive. So if you're doing it saying, hey, we need to save money, I mean, go try burning up your dust collector. If you're having fires on your site, that's another dead giveaway.
Yeah, it's difficult to anticipate in a manufacturing facility when workers are going to mix media in a workstation. Let's say you're doing welding for a month and then someone comes along and starts to grind aluminum, and that creates a problem. Are you seeing a lot of that in the field on some of your consultations?
Yeah, there's specific requirements definitely for metals and mixing, and we do see several cases where mixing, say, metal, aluminum, and iron, or other types of metals can lead to ignition sources inside of systems and cause dust explosions. So you have to be careful when you're mixing. And more broadly, yeah, it's hard to opt out without doing testing. But you certainly don't need to do testing. There are other bases of safety, if you're using them, that you could come up with that don't require testing.
That sounds like it comes back to the point of education and how there's a broader issue besides combustible dust itself. There's also general workers that need to be informed of some of the hazards that would affect them at the base level. Another question here. This is for Mark or Kevin. What kind of service area do you cover, and do you perform the physical installation for your projects in-house?
Yeah, I'll take that. Yeah, so we cover all over the United States as far as if, we sell mostly through distribution. So if they opt to contact us and we can go and service our equipment. Installation wise, we typically try to stay within 6-7 hours of our factory, but we do go beyond that in certain circumstances. So yeah, we'll do whatever it takes to keep the customer happy and satisfied.
All right. One more question here for Chris. A couple of things. I'm sure every situation is different. Typically, could you ballpark the cost of a dust hazard analysis based on process or square footage of a building or how many facilities a business may have? Is there a sort of a starting point that you can consider for costing?
Yeah, I mean, it is going to vary depending on your site size. The smallest amount that I've seen that really makes any sense, like if it's a really simple operation, just the man or woman power to send somebody out for a day, assess the site, and write the report, you're generally looking at maybe 8 to 12,000, and like 8's starting to get low. What you're going to get if you go any lower than that is somebody who only assesses parts of the hazards. So they just come in and say, oh, you need a dust collector, but they're not looking at your explosion protection systems. They're not evaluating really anything. If you do the math, you can't do a whole lot on less than that. And that's for a really simple site. The other side is infinite. You have a really big complex process and you got to have people on site for a week to assess it. Then it's tens, hundreds, but in the tens range. I'd say 12 is probably the lowest you're going to find, and even that's a really simple process. The flip side, the lowest cost that, like, generally when you have a shutdown, that's going to be your biggest expense. It's just the product you're not making. So if you're shut down for a day because you have a fire that wasn't evaluated, then you're going to kind of make up your money on the other side.
You come to the old adage, if you think prevention is expensive, think of the cost of an accident. So the last question for the day, it would be, who is qualified to perform a dust hazard analysis? What type of specific skills are necessary? Or qualifications as well, of course.
I guess that one's probably for me as well. Is that right?
Yeah.
Yeah, I mean, so the NFPA requirements for qualified person, let me pull up the new 660s to see what's in here. But they generally cover, they say in a very general sense, someone who has experience with the hazard, with the operation, and knows the dust hazard analysis process. So at Dust Safety Science and the Combustible Dust Training Institute, we break that down to three things. Do you know combustible dust hazards? Do you know the fundamental principles of how fires and explosions occur? That's step one. You need to know the process itself. So it's great if you've done DHAs your entire life in a woodworking facility, or various woodworking facilities, you've done 50 of them, that's great. Should you lead the DHA, the new nano titanium aluminum or nano titanium 3D printing application? Well, probably not, because you don't know that application. So application experience, the second rung, and then just experience actually running the DHA process. So even if you're an industry expert and you have done fundamental combustible dust training, but you've never led a DHA, you don't know how to bring the team together, you don't know how to write the report, you don't know how to make a good set of recommendations, you don't know how to rank those recommendations in a way that's useful for the site. Those all kind of come down to DHA facilitation. That's the third rung. So there are not specific standards set for NFPA on what those are. But our certifications are building towards that. So we do have a certified DHA leader program that we just had the first cohort starting on May 1st, actually, so in 2 weeks. And that build out those three things: fundamentals in combustible dust, understanding across a broad range of applications, and then how to actually go about leading, facilitating a DHA. It's not necessarily one person, but the DHA leader should have enough experience to be able to bring the team together, know what their limitations are, and bring in the subject matter experts from the sites that are needed to start to run those. So, and we're hoping that those requirements will be useful enough to folks to start to define who is a qualified person moving forward.
Well, that certainly helps to justify some of the costs that you were referring to a moment ago when there's that level of intricacy in the process. A couple more questions, if you don't mind. They're trickling in a bit here. Is NFPA 660 open for interpretation, or is this standard set in stone?
Well, it's an interesting question. So anything that's in the chapters, the chaptered sections, are considered shallows. So they're not open for interpretation. Anything that's in the appendix is open for interpretation. Those are shoulds. And that's up to whatever region you're in has it adopted 660 yet. And so if an insurer says you shall follow 660, then you shall be required to do everything in the chapters that are 1 to 20. If you're in a state that is running the International Fire Code that references 652, there's different years and different codes referenced in different ways. There are certain states that would none of the International Fire Codes are referencing 660 yet because it's too new, but they're referencing 652. And if they're explicitly referencing it, then now bring it in explicitly. So there's different kind of ways in which NFPA would be invoked. But in terms of the document itself, the shalls are in the chapters, and I guess shall not be interpreted any other way. Now everything's written in words. And the funny thing with words and people is that we can disagree on what those words might actually mean. So that's a bit of where the gray area comes in some of this application. But in terms of in terms of actually, that's how the best way to lay it out.
Yeah, it's still very fresh in a lot of people's minds, I would bet. So
it's not changeable. And the question's more about that. The version that's there is the one. I don't know. It's probably on a 2-year cycle. I'm not 100% sure about that, but you can put comments in for the next revision cycle. Whenever that new revision cycle comes up, that would be when they'd address and make changes then.
All right. I just want to end off with an equipment question, specific. Mark, if you could, or Evan or Kevin, if this pertains to your expertise, do collectors like downdraft tables that have a lot of open area still prevent an explosion hazard, since the unit has more open area than you would? Excuse me, I just have to reiterate that for a second. Has more open area than you would the size of an explosion vent of the enclosure. Is it really a risk for explosion because you can't build pressure? I guess what they're getting at is there seems to be more the input side of the table and the output side of the table offer more areas for pressure to be relieved. Would you have to put a rupture panel onto a downdraft table? Are there fire and explosion mitigation systems that can be added to downdraft, or are those even required?
Yeah, I think, the way we review that is that, we would rather have a downdraft table that is ducted to a unit outside. And I don't know, maybe Chris can chime in a little bit on that. But I would say that even though it would just depend on the type of dust and the KST value that would affect that. Chris, have you got any thoughts on that?
None that I could add here. You'd have to look at the actual specific circumstance and come up with an engineered design. A little bit out of my wheelhouse for figuring out on the webinar.
Yeah, I think that's a bit outside the scope of this. Chris, I'd invite you to put up that slide again with the QR code, if you don't mind. I think our viewers might, who missed that, might appreciate the chance to sort of scan that and get some of the back end information here that you've been referring to. Really excellent stuff. I'm glad that we had the opportunity to come today and showcase your knowledge and our expertise together. And Chris, if you could just walk us through this a little bit for for anyone that joined late.
Yeah, so we've had half a dozen or so people already do it. So just take your phone out, hold it over the QR code, and click. That will take you to my LinkedIn profile. Just connect there and just shoot me a message and say slides plus clean air. That way, I was answering to the people that come on there, but my team will pick it up in the morning and also get anybody else that comes in. And we'll send you the slides, and we got a couple cheat sheets that were made from some of these materials as well. If you have any other questions too, you can send them through there. Like I said, I don't know all the answers. I don't pretend that I do, but I do know a lot of the people. So if there is a question that can be answered, we'll get the right person to answer that for you.
That's excellent. And of course, I'd like to invite anybody that wants to reach out to us here at Clean Air Industries. You can reach us at clean-air.com. We'll be more than happy to get back to you and answer any of the technical questions that you didn't get an answer to today. So, and I'd also like to remind everybody that this webinar series that Clean Air Industries is doing is ongoing. Our next one will be on educational equipment. That's coming up, I believe, in June. And you be on the lookout for that information. We invite you to come down and learn a little bit about what type of solutions are also being done in the educational field. And at this stage, I'd like to thank everybody for visiting us and meeting with us. And of course, Chris, thank you very much for coming on and being our guest today and sharing a lot of very important information on the changes to NFPA 660. I appreciate it, and I'm sure all of our guests do as well.
Awesome. Thank you, everyone.
All right. With that, we'll say goodbye to everybody. Until next time, stay safe out there. Thanks again.
Thank you.
Thank you.